Somewhere inside a Chinese fab right now, roughly 6 out of every 10 wafers coming off Semiconductor Manufacturing International's most advanced production line are being scrapped, and Beijing has already decided that is acceptable. The bullish read says China just crossed 35% domestic equipment penetration inside its own factories, blowing past its own 2025 targets years ahead of schedule, with a $48 billion state fund still loading the cannon. The skeptical read says those wafers cost more to throw away than the Taiwanese foundry charges to ship a finished chip. 3 rounds settle which story is actually true, and the answer requires holding both numbers in your head at the same time. The rounds move from the equipment milestone to the yield gap, to the subsidy as strategy, and then to the price tag nobody prints. China's domestic semiconductor equipment suppliers have crossed 35% penetration inside Chinese fabs. That share is one the original Made in China 2025 roadmap did not expect until the end of the decade. The third iteration of the state investment vehicle, at roughly $48 billion directed specifically at artificial intelligence chip production and memory technology, is the mechanism that bought that acceleration. The bullish argument is compact. The West's equipment embargo has been partially routed, ahead of schedule, with capital still in reserve. The counterclaim is equally compact. 35% penetration is not the same as 35% capability. The equipment that Chinese suppliers are now shipping at scale covers the less demanding process steps: deposition, some etch, metrology at mature nodes. The hardest tools: extreme ultraviolet lithography, advanced overlay inspection, certain implant systems remain outside domestic supply. Penetration share measures unit count and revenue. It does not measure the portion of the process flow that actually determines whether a leading-edge wafer lives or dies. The 35% figure and the fund allocation come from Chinese state reporting and are widely cited in industry coverage. Independent equipment analysts broadly corroborate the directional trend while flagging that the mix skews toward mature node tooling. No public audit of step-by-step process coverage at leading-edge nodes exists from a neutral source. The number is real. What it measures is not yet what the bullish case claims it measures. Equipment share at mature steps is not a proxy for lithographic independence at the leading edge. A genuine milestone with an overstated headline, and the skeptics take this round on a narrow reading. Semiconductor Manufacturing International is producing chips on what the company describes as a 5-nanometer class node. That claim, taken at face value, places China inside a generation that only the Taiwanese foundry and Samsung have commercially mastered. The bullish inference follows cleanly. The technical barrier has been crossed, however slowly, and the trajectory is now the argument rather than the starting position. The production data, as reported, complicates that inference immediately. Yields on that node are estimated in the range of 30 to 40%, against the Taiwanese foundry's yields above 80% on comparable generations. A yield is not a footnote. It is the ratio of sellable chips to silicon consumed. At 30% yield, more than 2/3 of every wafer is waste. The Taiwanese foundry's margin structure works because yield losses are small and predictable. At these figures, the cost per working chip coming off the advanced line is a multiple of what the market would otherwise bear. The 30 to 40% yield range and the 80+% benchmark have appeared in analyst reports and trade coverage. They have not been confirmed by third-party process audits, and Semiconductor Manufacturing International does not publish yield data. Treat them as informed estimates. A chip that exists at 35% yield is not the same product as a chip that exists at 82% yield, even if both pass the same electrical test. The cost structure underneath the headline capability is the real competition, and on that measure, the gap is not a rounding error. The skeptics take this round more decisively than the first. Beijing has explicitly reframed the yield gap as a national security cost rather than a commercial failure. The third fund is not venture capital seeking returns. It is strategic infrastructure spending, closer in logic to a public transit system than a startup balance sheet. The argument is that judging Chinese chip economics by commercial yield standards misreads what the program is actually trying to achieve. If domestic production exists at any cost, the supply chain leverage that Western export controls were designed to create is partially neutralized. The strategic logic is internally coherent. The sustainability objection is also coherent. Subsidies on this scale are not infinitely durable, and the inefficiency compounds. Every wafer scrapped at Semiconductor Manufacturing International consumes imported raw silicon, domestically produced chemicals, equipment depreciation, and engineering hours, all of which are real resource costs, even when the capital outlay is state-funded. Running a fab at 35% yield on leading-edge silicon is roughly analogous to a steel mill, where 2 out of every 3 ingots crack before they reach the rolling line, except that steel ingots do not require a $200 million lithography machine to attempt. The scrap is expensive at both ends. A fab running at this yield on advanced nodes is also producing less learning curve data per dollar spent than a commercial fab at 80%, which means the technical improvement rate may be slower than the investment level implies. $48 billion is large in absolute terms. Spread across artificial intelligence chip and memory build-out simultaneously, it is thinner than it sounds. Beijing takes this round on strategic logic, narrowly. The commercial critique is correct. The strategic reframe is also correct. History suggests a subsidy-sustained fab can be a durable geopolitical asset for a window, and Beijing has been clear about what window it is buying. The round goes to China for clarity of purpose, not efficiency of execution. The round that matters most is not about whether Semiconductor Manufacturing International can produce a chip on a 5-nanometer class process. Reports suggest it can, at some rate, at some cost. The decisive question is whether the subsidy structure underneath that capability is self-reinforcing or self-limiting. The $48 billion does not get spent once. It gets consumed in operating losses, yield improvement cycles, and equipment refresh that a commercial fab would fund through margin. If yields improve towards 60 or 70% over the next several years, the math begins to close. If they plateau, held back by the absence of extreme ultraviolet lithography, or by the engineering depth required to tune processes without access to certain metrology tools, the subsidy becomes a permanent structural feature rather than a bridge to self-sufficiency. The case against that finding runs as follows, and a fair reading of the evidence requires stating it fully. The analyst framing still judges China's chip program by the standards of a commercial semiconductor business, which is precisely the frame Beijing has rejected. The Taiwanese foundry's 80% yield matters because that foundry must generate returns for shareholders and price competitively in a global market. Semiconductor Manufacturing International does not operate under those constraints. A state-backed fab that produces enough advanced chips to equip domestic artificial intelligence infrastructure at whatever cost per die has achieved its strategic purpose regardless of what the income statement looks like. There is also a learning curve argument the yield gap framing undersells. Every cycle of a high-volume production process, even a low-yield one, generates process data. The question of whether Chinese engineers can close the yield gap without extreme ultraviolet lithography is genuinely open. Some process improvements historically came from better process control and material science rather than lithographic resolution alone. The honest acknowledgement sitting at the center of this whole contest is that no independent party has access to Semiconductor Manufacturing International's actual process development roadmap, yield improvement rates quarter over quarter, or the internal cost accounting that would settle whether the subsidy math is converging or diverging. The yield figures in circulation are estimates. The equipment penetration figures are directional. The $48 billion is the one hard anchor. And even that number does not tell you how it is being allocated between memory, leading-edge logic, and mature node capacity expansion. That dissent is well-founded on the commercial versus strategic framing question, and it lands. It does not rebut the central finding, which is that the cost is real, it is being absorbed, and the long-run question is absorption capacity, not technical ambition. The Taiwanese foundry wins the commercial round by a wide margin that is not seriously in dispute. China wins the strategic framing round in the sense that it has redefined what winning means for its own program. The round that actually matters, whether a subsidy-sustained, yield-constrained advanced fab becomes a durable industrial asset or a permanently expensive demonstration, has not been decided yet. The yield trajectory over the next manufacturing cycles will answer it, and that data does not exist in any public form. The export restriction that was supposed to foreclose this contest instead revealed what Beijing was willing to spend to keep it open. Semiconductor Manufacturing International's 5-nanometer class line is not proof that China caught up. It is proof that China calculated the price of staying in the fight and paid it, and that the original restriction, by forcing that calculation, made the subsidy commitment explicit rather than theoretical. $48 billion and a 35% yield. That is not a chip story. That is a balance sheet that has decided geopolitics is worth the write-down. The round most open to challenge here is the equipment penetration round. If domestic Chinese tooling has moved further into leading-edge process steps than the public record shows, the entire yield gap argument shifts. Drop the evidence in the comments if you have it. And if the cost accounting underneath the next headline about China leapfrogging is the question you want answered before anyone else frames it for you, subscribe and turn on notifications, because that is the only thing this channel tracks.